Imagine, back in the 1980s, a groundbreaking discovery was made in the heart of the African savanna. This woman noticed a fascinating behavior among elephants that would change our understanding of animal communication forever. While humans have ventured into space and even tried to communicate with aliens, we still struggle to understand the other species on our own planet. But could this change in the new AI era? Joyce Poole, a pioneering researcher, observed that when an elephant called out, sometimes only a specific individual would respond. This sparked a decades-long journey into the world of animal communication. Now, in the era of AI, researchers like Joyce and her colleagues are decoding the hidden languages of various animals. These discoveries are reshaping our understanding of the animal kingdom and revealing the intricate ways creatures communicate with each other. Decades later from her observations, she partnered up with Pardo, who designed a study around her observations. Now, this man recorded calls with careful behavioral observations so they can know who made each call and who the call was addressed to and the context of the call. They encoded the acoustic information from the recordings into a long string of numbers. Along with the data Mickey collected about the calls, they fed nearly 500 different calls like this into a statistical model. And when given the acoustic structure of a new call, the model could predict who the receiver of the call was, much better than chance. In other words, evidence suggesting African savanna elephants give each other names. This is just one example of how machine learning is decoding complexities in animal communication that humans can't detect. And now some AI researchers want to take the next step. Large language models, like the ones that power chatbots but built for interspecies communication. When researchers study animal communication, they usually employ a few methods: recording their vocalizations, observing and documenting the behavior and context around those sounds, and sometimes doing a playback to measure the animal's response. All of these areas are already being impacted by AI. Recordings from the field don't usually sound like this. They often sound like this. Multiple animals vocalizing on top of one another in a noisy environment. This is known as the cocktail party problem, and it's a common issue in the field of animal research. But machine learning solved a similar problem in human speech recognition. AI researchers trained a model called deep karaoke on lots of music tracks, where instruments and vocals were recorded separately, then also on the fully mixed tracks, until it was able to do the task of separating out instruments and vocals in new music clips. Recently, AI researchers have had some success applying similar algorithms to animal sound recordings, which means you can take a clip of a group of macaque monkeys and single out one discernible call. Researchers could also start using AI in how they use playbacks in the field. You may have seen AI models that can be trained on lots of examples of a sound recording and then generate another unique version of it. AI researchers are starting to develop similar models for animal recordings. These are all types of supervised learning. That means that the model gets trained on lots of examples labeled by humans. And in the elephant name study, researchers were able to feed a model their observations, which, along with the sound data, helped them detect something in elephant calls they couldn't through observation alone. Yossi Yovel trained a statistical model on 15,000 Egyptian fruit bat vocalizations, and it was able to identify the emitter of the call, the context of the call, its behavioral response, and who the call was addressed to, and they annotated them manually. You see, this is the restriction of the study, because maybe they missed something. In the end, they are humans, not bats. They are limited by what we humans already know about animal communication in order to label the training data, and we don't know a lot. That's why some AI researchers say self-supervised models hold the most potential for decoding animal communication. This is how natural language processing models like ChatGPT are trained. Instead of human-labeled examples, they are trained on a large amount of unlabeled data and then consorted according to patterns and categories it detects all on its own. For ChatGPT, it learned from all the books, websites, social media feeds, and anything else it could scrape from the internet, and came to its own conclusions about how language works. This is Asa Raskin. He co-founded the Earth Species Project, one of a few organizations that want to build models like this for animal communication. Now he says that every language has a shape that AI discovers. What he means by language having a shape is that language models are built out of relationships among words. Words that mean similar things are placed near each other. Words that share a relationship share a distance and direction. So, man is to king as woman is to queen. So this is the shape of all those relationships among the English language's 10,000 most common words, visualized here by the Earth Species Project. Flattened out, it looks something like this. And in 2017, something really miraculous happened. Researchers discovered that you could take the shape of any one language and match it to the shape of any other language, and the point, which is dog, ends up in the same spot. This idea that similar words can be located in other languages in roughly the same place is what gives the Earth Species Project hope we could do a version of this for animal communication. This is complicated though, because we know that animals don't just communicate with sound, but with other senses too. But Aza points out that we can learn from the fact that image generation models like DALL-E and Midjourney are built on the same large language model structure used for text. It turns out, behind the scenes, it's these kinds of shapes. There's the shape that represents sound, the shape that represents images. Those two shapes get aligned, and now you can translate between images and text. Their expectation is that where non-human animals' communication would line up with ours will tell us even more about what we have in common. One concern with this plan is related to a step in self-supervised learning called validation, meaning humans still need to refine these models by grading them on their answers. How would we do that in a communication so foreign from our own? We also might have too high expectations of this overlap, or the capacity for having a conversation with a non-human animal in a shared language.
Kurt, how are you doing, dude?
So I'm about to translate that into a meow.
And about shared experiences. In order to build these models, the first step is collecting a lot more data on animal sounds than exists right now. So at this moment, Joyce Poole is building a database with all the individual calls for elephants, so close to 10,000 records in that, which is very small for machine learning to learn a new language. Around the world, animal researchers are in the midst of a massive data collection effort, tagging and recording animals with video and sound and spatial data to feed these data-thirsty models. Time will tell whether true interspecies communication will be facilitated by AI, but researchers hope that discoveries along the way will continue to have an impact on our appreciation and protection of the species we share the planet with. And that's it, bye.